All right, crew, here we are again, doing some geometry. Chapter 11, Section 6, Surface Area and Volume of Spheres. Oh, I love this. It's the ball section. Who doesn't love a baller? A sphere is the locus of all points in space that are a given distance from the point. So think about one central point, and then whether you're forward, backwards, front, behind, diagonal, you're creating a sphere around which is all the same distance from this one central point, which brings us to the center. It's the point that is equidistant from all other points on the sphere. So we have our center point, and then all the other points on the sphere are represented. It's interesting I don't have a picture. Hold on, let me go grab a picture for you. Here we go. I'm much a more visual learner. All right, so we'll put our little dot at the center. Oh, it's in front. Okay, so we'll put our little dot at the center. So it is all these points around that are the same distance from our center. All right, let's look at what that little r means. R radius is a segment from the center to a point on the sphere. It's the distance from the center to all the other points on our sphere. Okay, my friends, listen carefully. This is pronounced chord. So the CH doesn't make the ch sound, it makes the k sound. So it's chord, which is a segment whose endpoints are on the sphere. So if we have a point here on the sphere, and we come across, now I'm here on the sphere, I'm called a chord. And the diameter is a chord that goes through the center of the sphere. So like this line right here, it goes from one side of the sphere through the center and to the other side of the sphere. That is the diameter of the sphere. All right, surface area. The surface area of a sphere with radius r is 4 pi r squared. So it's like the area of one circle times 4. And all right, you guys, here is what baseball looks like when you take the leather off the outside.
Within a window of 100th of an inch thick.
So I want you guys to see, it's two of these kind of rounded, they look like the sleeping mask shapes.
Pretty crazy.
And the way I remember it, if you're a baseball fan, this is what baseball looks like when you take it apart. If you look, it's like this could be a circle, this could be a circle, this part on top could be a circle, and this part on bottom could be a circle. So the surface area is 4 times the area of a circle.
Now take a look right here. It's hard to see, it's kind of faint, but every baseball has a special 6-character code.
So anyway, I just wanted to show you guys, maybe give you a way to remember, and just to give a shout out for what's inside of a baseball YouTube guy.
Printed on the inside. That's one of the many quality control methods.
All right. That's what I wanted to show you. Okay, let's see how we apply that. We're going to find the surface area of the sphere. Let's remember that the formula is 4 pi r squared. Not too shabby, not too difficult. So surface area is 4 pi times 2 squared. 2 times 2 is 4. 4 times 4 is 16. This is 16 pi. 16 pi is 50.3. And those are square inches. Okay, given a scenario where we have the diameter, we have to cut the diameter in half to find the radius. So our surface area would be 4 pi times 4 squared. 4 squared is 16. 16 times 4 is 64. And then 64 pi is 201.1. And that is square inches because we're in area. Okay, let's go apply this. I'm going to skip over this one. Let's talk about the great circle. Here's the definition of great circle. If a plane intersects a sphere and contains, so like think about this plane here going off forever, not just ending at the edge of the sphere, and contains the center of the sphere. So it's a plane that goes through our center. Then this intersection is a great circle. So it touches the kind of like the circumference of one little circle on our sphere. A hemisphere is just half a sphere, so it's one side or the other. Yay. Okay. A great circle on a sphere measures 12 pi feet. What is the surface area? So the great circle, so if you took a measuring tape and measured all the way around the circle, it would equal 12 pi. So this is the circumference. My handwriting is struggling today. So the circumference formula is 2 pi r. So let's go ahead and find what r is so we can find the surface area, which the surface area formula is 4 pi r squared. So if they gave us that the circumference, which is the measure of our great circle, is 12 pi. The formula for circumference is 2 pi r. We're going to divide both sides by 2 pi and realize that r is 6 feet. So then we can come here and we can go, okay, our surface area is 4 pi times 6 squared. 6 times 6 is 36. And 36 times 4 is 144. We multiply 144 by pi. We get our approximate answer for surface area is 452.4 feet square. Okay, that's fun with the great circle. All right. So we're going to talk volume of a sphere. The volume of a sphere is 4/3 pi r cubed. So we keep the 4 from the surface area. We divide it by 3, and I think of it like because volume is cubic. And then our r becomes cubed because we're talking volume. 4/3 pi r cubed. So I'm going to show you how to use this formula. If you want a video explaining where it comes from, here is a YouTube video. Shout out to Babel Math for putting that together. But I'm going to show you just how to use this formula, not necessarily how to derive it. We have a radius of 4, And I'm just going to put all this in my calculator. I'll show you. 4/3 pi 4. And then I need a cubed. So my cube is this little, it's called a caret. I also sometimes will call it a hat. You may have a y to the x. Just find out where on your calculator, you might have a cubed button just straight up. Find out where your calculator, how to do this on your calculator. If you don't know, you can Google the name of your calculator. This is a TI-30XS, or whatever you have. If it's your phone, how to cubed on the phone calculator, or ask me in class when you see me. So this is 256 pi over 3, or approximately 268.1. Okay. Example 4. To make a steel ball bearing, which is a sphere, to make a steel ball bearing, a cylindrical slug, this is this guy, is heated and pressed into a spherical shape with the same volume. What is the radius of the ball bearing made from this slug? Oh, so we are going to make a ball out of this cylinder. They're going to have the same volume. So the volume of the ball is going to be equal to the volume of the cylinder. So we can find the volume of the cylinder. It is the area of the base times the height. So we got pi times r squared times the height, which is 2. So 1 squared is 1. Essentially, the volume is 2 pi. So the volume of the cylinder is 2 pi. The volume of the ball is also going to be 2 pi. So let's put in our 4/3 pi r cubed. In for our volume, and we're going to solve for r. So the first thing, let's go ahead and times it by 3. I'm just going to unpack this in a way that we can track it a little bit better. 6 pi. And then divide both sides by 4 pi. R cubed equals 3 halves. And then the cubed root, of 3 halves is what our r is going to be. If you're putting this in your calculator, you may want to convert 3 halves to 1.5. So it's just a little bit easier to type. But I'll throw it in my calculator with the fraction because, you know, whatever, I don't care. So my calculator wants me to type in my root. So if you look, it is, if I hit the second button and then this root, I can do whatever root I want. I can do 4th root, 5th root. In the volume case, I'm going to be doing 3rd root. So then it's second, hit the root. Oh, yeah. And then the fraction 3 halves. Okay, enter it up. 1.14. So the radius is 1.14 centimeters. Yay, that was fun. Okay, 3 tennis balls are sold in a sleeve. 3 tennis balls in a sleeve. What is the minimum volume of the sleeve if the tennis balls have a radius of 2 inches? Okay, so let me give you, the sleeve is just the can of tennis balls. We have 3 of them, 2, 3, chilling in there. The tennis balls have a radius, so from center of 2 inches. To find what is the minimum volume of the sleeve if the tennis balls have a radius of 2 inches. Um, so the sleeve shape is a cylinder. So the volume of a cylinder is pi r squared h. It's the area of the base times the height. The area of this base, well, to minimize the volume, it should have a radius of 2. So it's going to be pi times 2 squared. And then the height, it's the height of 3 tennis balls. Well, I know halfway across a tennis ball is 2. All the way across a tennis ball is 4. And I have 3 of those. So 4 plus 4 plus 4 has a height of 12. Times that by 12. What? So awesome. So 2 times 2 is 4. 4 times 12 is 48. This is 48 pi inches cubed. 4. Oh, sorry. 150.8. All right, example 5. Okay, you guys, take a moment, go finish your homework assignment. When you're finished, come back here and check your answers. So funny. Sorry. Here's the start of your practice. I don't know why it ended up on the wrong page. And then here's the end of your practice.